Good morning. Welcome back to Speech Understanding. So today's lecture will probably be quite a bit shorter than most. Last last time, as you know, I taught you how to use the API that allows you to use the Google Speech Recognizer, and that was the speech recognition Python package, which you can just look up as speech recognition Python package, and it will come up. There it is. The speech recognition package, as you know, is as I told you last time, is actually a module.
But in places where the beef specialty, they're going to look for chicken for.
The speech recognition package is a module in Python that allows you to use any one of these automatic speech recognizers. The CMU Sphinx is open source. Most of the others are closed. OpenAI's Whisper is available. The recognition engine is available. The training engine is not available, but produced by a variety of companies and a variety of organizations. Today, we're going to learn how to do text-to-speech synthesis, how to take a text input and convert it to speech in Python. And the only really easy to use package for this in Python is the Google text-to-speech synthesizer. So we're going to be using the Google text-to-speech synthesizer, GTTS, which is a Python module that allows you to access the Google Speech Recognizer. You need to be connected to the internet. Basically, this is a package that takes text from your computer, uploads it to Google's server, gets the resulting audio from Google's server, and downloads the resulting audio back to your computer again so you can play it. It's very easy to use if you're connected to the internet. If you're not connected to the internet, it's impossible to use. So let's go ahead, first of all, to install it. You'd use the usual syntax, pip install GTTS. The only thing complicated about it is the capitalization. When you download it, the G and the S have to be lowercase and the two T's have to be uppercase. But then when you actually import it, it's all lowercase, GTTS. So I don't know why they did it this way. They made it more complicated than it needs to be by requiring this kind of capitalization. When you install it, it has to be lowercase g, uppercase T, lowercase s. So we can install it. And when I try to install it, it will say requirement already satisfied because I have it already installed on my computer. And then once you've installed it, then you can read in GTTS. GTTS can't play the audio directly. We could use Librosa to read in the audio, or we can use a package called Soundfile that we have not previously used. Let me look up Soundfile online. Soundfile is just another module in Python that allows you to read and write audio files. It's similar to Librosa or PyAudio, but it's somewhat simpler. In fact, Soundfile is quite a bit simpler than Librosa. It really only has modules that allow you to read and write sound files. So you can read in a WAV file using sf.read, and you can write out a sound file by creating sf.soundfile as the file and then writing to it. So we'll install, make sure the sound file is installed on my computer. It should already be installed. And then we can use GTTS. And it's very simple, which is why this lecture is going to be a very short one. We import GTTS, we import sound file, and then we import IPython in order to be able to play it back again. Let's say that we want to synthesize the text korewa gosei onsei desu. And we'll synthesize that using Japanese language. We have to specify the language if we want something other than English. English is the default. So let me run this, and it will produce a TTS object that has the audio inside it, but the audio is not easy to get out. The easiest way to get the audio is to simply save it to a file. The audio is in MP3 format by default. So we can look up MP3 audio format. And you discover if you look up MP3 audio format that it's an international standard developed by the International Standards Organization, ISO. It was developed originally in 1991. Yeah, originally defined in 1991. So it's a very old standard, highly compressed audio file format. We want to save it as MP3, and we want to read it in using, you can read it in using Soundfile or using Librosa. Those two will work just fine. So we can read it in, これは合成音声です, and then we can play it back.
これは合成音声です。
Can you hear that audio that it plays back? Can somebody tell me? Is that audible to you?
これは合成音声です。
Okay, I'm going to assume that that's audible for you. Let's look at this object in a little more detail. This object TTTS is a Python object, right? It's a complicated structure that has a lot of information inside of it. So let's go ahead and just create this object and then print it out and see what's contained inside. Let me create desired text. Oh, I've already got desired text. So let me just do TTS. Actually, I've already got that TTS. Let me just print out the content of that TTS object. And let's see what kind of object it is. If we print it out, it's a TTS.GTTS object. Let's see if we can call help on it. Let's see what kind of information we can get. Help on GTTS object. So here's, this is an object that was actually created by calling the Google speech recognition, the Google speech synthesizer using Japanese language and using this desired text. And what we have this GTTS.TTS object, and this GTTS.TTS object has the text is the text to be read, so we could print out the text. The TLD is the top level domain for the Google Translate host that we connected to. That's the web host. Let me just print out all these things. And then let's say the TLD was, and we'll print out TTS.TLD, and language printed. We'll print the language was. And what else is there? Language check, strictly enforce an existing language. I think that's probably going to be negative, but let's find out. Preprocessor functions will probably be just the default, a list of 0 or more functions that are called to pre-process the text before tokenizing. So it removes tone marks, it marks the ends of lines, it expands abbreviations and so on. Let me skip over that. The tokenizer function, how does it divide the input text into words? In Japanese, it has to pay attention to the separation between characters. In English, it would have to pay attention to words. Get the TTS API request bodies. That's not interesting to us. Save the, do the TTS API and write the result to a file. So actually, the audio is not created until we call save. When we call save, then it actually does the API request online, gets the audio back again, and saves it to the file. We can also use stream in order to stream the bytes. And so we can finally, let's print the bytes of the audio are, and I'll print TTS.stream, and that should generate the bytes of the audio. And it will print a long list of bytes that will be kind of nonsense, but that's something that we can look at. So let's look at the content here. So here's the help. Oh, let me just comment out the help because I no longer need that. Let's run this again. The text was Korewa Gosei Onsei desu. The top level domain was Kwan. The language was Japanese. The language check was true. And the bytes of the audio are, and this is a generator TTS object. So this is a file. Let's see. I wonder if I can open that. Let's see if I can read it this way. I'm not sure. Nope, it doesn't support that protocol. All right, well, we can't. TTS.stream will allow us to read the individual bytes somehow, but I'm not sure how. So far, all we have is we know that this is the text, this is the top level domain that it accessed, this is the language, and this is the language check. And we can save that audio to a file using the TTS.save method. And that's it. That's really just it. We call GTTS, tell it what the text is, what the language is, and then we save the resulting audio to a file. And then now we have that file, now we can do something with it. One thing we can do is we can use the speech recognizer to check the output to make sure that the output actually worked. So we can write, we can read in that sound file. So for example, if we have the speech.mp3 file here, we've created speech.mp3 by saving korewa gosei onsei desu. So we can read in that file, and then we need to convert it to a .wav file in order to be able to read it into the speech recognizer, right? The speech recognition toolkit requires WAV input, and so we have to convert it from MP3 to WAV. So we'll convert it from MP3 to WAV, and then we'll read in speech.wav as the source and try recognizing it and print it out. So if we read that in, the person in this audio said korewa gosei onsei desu, which does not match the desired text because the desired text had no space. All right, let's add a space to the desired text. I think that won't change the audio at all. The audio for korewa with a space should be exactly the same as the audio for korewa without a space. So let me add a space inside of the text file.
これは合成音声です。
And then let me read and write that audio file. And then let me run the speech recognizer, and now it should match. Now it matches because I've just changed the text to add this space. Obviously, we need to do a better match. If it cares about spaces, then it's not really paying attention to the content of the file, but clearly we were able to run automatic speech recognition. So here I ran the recognizer with the Japanese language on that audio, and I got back the same text that we used to synthesize it initially. And so we can see that in this way we could do sort of a check, a quality check to make sure that our speech synthesis is doing the desired thing. So now that we have speech input with the recognizer and speech output with the synthesizer, now I'm going to use them both to create an electronic parrot, right? A parrot is a bird that repeats everything that you say. So let me create an electronic parrot that will be a program that repeats everything I say. We'll say, hello, I'm an electronic parrot. Please say something and I will try to repeat it. And then we will open the speech recognizer and we will listen to the microphone. We'll adjust for the background noise in order to minimize the background noise. And then we will listen to that source microphone. And if we hear anything, we'll use the Google Speech Recognizer in order to try to transcribe it to text. All right, if we hear something, we'll say, I heard what you said and it was this text. And then we'll try to save that audio as parrot.mp3. So we'll create a GTTF object, you said, and then whatever I say. And we will then save it as parrot.mp3. And then we'll read that back in using Librosa in this case. We could use Librosa or sound file. And then we'll play. And then we will generate an IPython display to show that audio. So let's see if we can make all of this work. I've defined that file. Now let me see if that format exactly as I have it will work this time. Hello, I'm an electronic parrot. Please say something and I will try to repeat it. It says, I heard you say, hello, I'm an electronic parrot. Please say something and I will. All right. Is it going to generate? Now it should generate the IPython object and show it. There it is. There's a IPython object. Let's see what it says.
You said, hello, I'm an electronic parrot. Please say something and I will.
All right, let's try something else here. Kittens are cute. Oh, I said that kittens are cute. Did you understand me this time? Oh, why are you not understanding me? I don't understand.
You said, why are you not understanding me?
All right. So now we've got our parrot is speaking. We can talk to it and it will understand what I say and it will generate the text. And then from that text, it will generate an audio file to play back to us. That's all we have this week. With this API, automatic speech synthesis is very easy. You remember that it's actually quite complicated. We have to generate the Fourier transform and scale each of the harmonics using the appropriate magnitude and phase. which changes as a function of time. All that is being done for us by default by the GTTS module. And so for the homework, we're already at the homework. All that we really have to do is create one function called synthesize. This synthesize function takes in a text and a language and a file name. It uses GTTS to synthesize the speech and then writes it out to the file name. So let me go ahead and open up the homework. All right, first we'll get rid of the runtime error. And then first thing we want to do is we want to generate the text. And let's see, we can do that by, we want to type TTS equals GTTS.GTTS text language. So we want to create a TTS object, which is GTTS dot, what is the capitalization? The TTS is capitalized. The TTS, and the text is the input text, and the language is the input language. And then we want to save it to the file name. And I think that should be all that we need. Let's find out. I think it's just those two lines. All right, let's try it.
This is speech
There we go.
synthesis.
Let's try. Well, we could change it to any other language by changing the language identifier and by changing the appropriate text. But now that we've got that running, let's check with grade.py in order to make sure that it matches the previous the previous example, and it looks like it matches. So now we should be able to open GitHub Desktop and just check it in. Hit it locally, and then push it to the origin. And then let me open up GitHub in order to make sure that it got checked in correctly. This is lecture 12. And there it is. TTS equals GTTS text language, TTS save file name. So we can take this URL, copy it, and paste it into homework 12. So if you go to homework 12, you should be able to just paste in the URL here, and then I can assign the grades. It's really that simple. So this week is a short lecture. Next week will be somewhat longer because next week I'll be teaching you everything that you need to know for this course about HTML. And as you know, there are entire courses at KCGI on the subject of HTML. If you've taken a course on HTML, that will help you next week. But if you haven't taken one, don't worry. I will go through everything that you need to know for this course in order to be able to use HTML along with speech synthesis and speech recognition. In the meantime, let's go ahead and take attendance already. All right, everybody, please go ahead and register your attendance using this code. 15511. E2GoGo E2T. I see there are 9 people logged in, so we should get 9 people registering attendance. I see 2 people already. Thank you. Now 5. Thank you. Can we get 4 more? And 6. Can we get 3 more people? Oh, now there's 11 people online. Maybe we can get 10 people to register their attendance. Here's the code. Please go ahead and register. Thank you. Now we're up to 7 people. Can we get 3 more? There's 3 more of you here. Now we're up to 8 people. Can we get 2 more people? There are two more people here. Let me turn off the recording.